Okay, there we are. Here are the anonymous ones. Okay, so yeah, you can see that there were 9 submissions. Almost all of them used hard coding, and one person uses soft coding. I'll explain what that is, and I'll explain how you were supposed to solve the exercise. Let's have a look at the first one. This one has a lot of gray areas.
Your screen isn't showing on the...
Oh, it's not. Okay, that's makes it a little bit harder to understand. Yeah, there we are. Okay. So the assignment was to draw the COVID map using the example shown here. So you were just supposed to copy it and then paste it into an R Markdown file. That's what everybody did. And then there was the assignment over here and the data cleaning assignment. And at the end, if you were finished, you could do the challenge where you had to show the number of cases per population size in Asia. So you had to recenter the map and you had to add a new variable to the plot. So this is one person's solution. Let's have a look at what we see here. So this is the default exercise, the first one. And then over here we have an attempt at showing the population estimate. We see a lot of gray areas here, and just it takes some time, like a minute or so, to have a look at this graph, see if you can figure out why there's so much gray in this map. Anyone have an idea? Yeah?
The graph on the right only goes to 70 million, and for example, India has 1 billion inhabitants, so it's off the scales.
Yeah. That's correct. Let me repeat it in front of the mic. So the legend still shows the maximum for the number of cases, which at the time was about 60 million. But there are a lot of countries with more than 60 million inhabitants, and there's no color for that. India, China, Russia, but even the Netherlands, I think. Oh yeah, no, the Netherlands still has a color, but most countries are gray now, most of the big ones. Because the inhabitant number is simply bigger than the maximum number for which there is a color. So the way to fix that would be in the code. This one. Yeah, let me make this a little bit bigger as well. In the original script, there's a line that says max C, which is the maximum number of cases, right? And I take it from the COVID-19 confirmed variable. What you were supposed to do is you were supposed to change this variable to take the maximum of the Earth population estimate. And then it will also change the legend. Okay, so that's that one. Let's go to the next one. Here we have one of the hard-coded solutions. So I'll explain what that is. Anybody knows what hard-coded subtitles are? Anybody watch movies illegally? Okay, just me then. So if you have a movie, you can have soft-coded subtitles or hard-coded subtitles. Hard-coded means that they are written into the video file. You can't remove them. So this I would call a hard-coded solution because here we have a very nice map which shows the number of cases per population estimate. And I was wondering, how did they get the color scale to be, somewhat indicative of the differences? And turns out a lot of people had a very simple solution for this. Just change the limits to something that works. So in this case, 0.07. This is called hard coding because if I change this to a different date, then the maximum number of cases per population estimate will also be different, and then this may no longer work. So it's not wrong. It definitely works for this assignment if you're just supposed to do it for one single day. But in general, it's always nicer to have a soft-coded solution, so to program it rather than entering a number. So over here you could have max and then Earth population estimate, because then it will work for any code. You don't have to have it for a specific day. Let me quickly check whether people can actually hear me on stream. Okay, no comments usually means that it's okay. Yeah, so this is a hard-coded solution. There's another way to do it. I call it hard-coded alternative. So this one's also hard-coded, simply by dividing the maximum number by, what is this? 181.8 million. That also works. I don't know what happened to the legend here. I think that's, maybe suppressed. But anyway, it's another way to do it, just divided by another number, which you can also call scaling. But let's have a look at the soft-coded solution, which is the only different one. And yeah, it should look somewhat similar. Of course, you were allowed to change the color scheme, so they all look a little bit different. But here as well, we can see the countries with a relatively larger and smaller number of cases. The only downside to this one is that the maximum population is, of course, the maximum population on Earth. And we're not looking at Earth, we're looking at Asia, but that's nitpicking, I think. This is a very nice solution, because what did they do? They just created a new variable that calculates the maximum for Earth population estimate. And that way, whatever date you change this to, it will always work. Whatever area you're looking at, you have a nice solution. Then they did something else. They multiplied it by 100,000 to get the familiar, as they call it, hidden ratio, which is the cases per 100,000 inhabitants. All the way at the end of general research skills, we will use hidden ratios, maybe once. But it is something you see very often in newspapers and in general when reporting data on cases. Okay, so that was a nice solution. So there were 9 people who submitted a solution. I don't have 9 beers. I do have 6. So the soft-coded solution, I will, when I turn off the stream, I'll show the name, can pick up the price. For all the other ones, as a, to console you, there's still cake left. So the other submissions can have a slice of cake instead. Okay, there's one here I named Hardcoded 100. Let's see what's different about this one. And that will be the last one I show. Oh yeah. Here we have yet another solution, which I think is quite nice. Because what happens when you multiply a proportion by 100? What does this show? Yeah, shows a percentage. So this is very intuitive for people to interpret. You can read the color and they can see what percentage that corresponds to, which I think is a very easy way to interpret data. So that's also a nice solution, simply by by setting the, this is a hard-coded solution, but at least it's a logical number to choose, namely 100. And then, of course, you have to multiply the proportion also by 100. Yeah, so that was a bit quick. I will also make a video where I more slowly explain how the whole script works, but we're not going to do that now because we already discussed it yesterday and you all worked on it yesterday. If you do have questions about it, you can ask, of course, if you're here, you can ask me now. Otherwise, you can post it on Brightspace, and then I will have a look. Okay, so that's all for that one. Okay, no problems with the stream, that's great. Then let's have a look at what we're doing today. We're not drawing cakes, we're not making a map of coronavirus cases. Today, unfortunately, is a little bit more boring. It is a very useful skill. This is something that you will be doing a lot. You'll probably do it at some point during your internship, and you will definitely do it a lot of times during the general research skills course. So this is a nice practice. If you can solve at least until the medium difficulty exercise, then you'll have a lot less trouble during the general research skills course keeping up with all the assignments. So what are we going to do? We're going to read and manipulate data. So I have 2 different examples. I have an Excel file and a Google Sheets file, and a short video on how you can read data into R from Excel or from Google Sheets. There are many different ways to read data in R. For very large data sets, there are also much faster ways than what I'm showing here. But this is the easiest way. This is almost never goes wrong. And if it does, there's a very simple solution. The one thing that can go wrong, it's also addressed in the video, is in some countries, the Netherlands included, the decimal separator, so if you have a number less than 1, is a comma. And the file type that we're going to use is comma separated values. That doesn't work. So then instead of a comma, it will separate values with a semicolon, so puntkomma. But the good news is, instead of using read.csv, there's a function called read.csv too. And that one works for countries where the decimal separator is a comma. So if it doesn't work, just add a 2 after the function and it will work. Yeah, the rest is explained in the video. It's only 3 or 4 minutes. Okay, what are we going to do? We're going to convert data into tidy format. So tidy means that every column shows a variable and every row shows an observation. So here's an example. This is the iris data set. And here we have 5 variables. We have the dimensions of the flower. So how long are the sepals of the flower? How wide are the sepals? And same for the petals. This is in millimeters, by the way. And we have the species. So one row is one flower. And one flower has a sepal length, a sepal width, etc. Now, then, of course, the question is, what is untidy data? Here's a simple example. Let's say that you did a Qpcr experiment. Everybody knows what Qpcr is? Quantitative Pcr. Okay, a quick recap. Qpcr is when you want to know how much of a certain gene product is in your sample. The way to do that is by amplifying it with PCR. And every amplification step, you will see a fluorescent signal proportional to the amount of DNA. And once the amount of fluorescence is large enough, once it's detectable, you call that the threshold PCR cycle, CT, and that's when it is detected. So the lower the threshold C value, the lower the CT value, the earlier the DNA was detected, and because you're amplifying it, earlier detection means that there was more DNA in your original sample. Yeah, that's Qpcr. Very short recap, lower values, more DNA. This is not tidy, because here we have 5 different genes, A, B, C, D, E. Yeah, I just showed the first 6 rows, but it goes on after this. And we have 2 treatments, control and ADH minus. That's all fine, but here we have 3 different experiments side by side. This is something you'll see a lot, and yeah, of course, I work with data every day, you probably don't. So a lot of people store data like this simply because it's intuitive and it seems like it belongs together. But this is actually not very convenient if you want to do analysis. What you would want to do is convert it into this. So this is the tidy version of the same data set. Let me try and make it a little bit bigger. Where one row is a single experiment's outcome. Yeah, of a single gene, of a single treatment. So one CT value. A quick way to memorize tidy data is that the outcome, if there is one, there should only be one in every row. Yeah, so rows are observations, columns are variables. Now, one quick recap, why was the other one not tidy? This isn't tidy because we have multiple observations. That one of the first experiment, the second one, and the third one, all in different columns, so that's not tidy. So the exercise of today is very simple. There are 2 different untidy data sets, and you're going to use R functions to convert them into tidy data sets. I'll be here to help. There are also a couple of hints, like which functions you can use, and yeah, there's some help files that you can look up that might be useful. The first one is supposed to be easy, but this is the first year we're doing this, so sorry if it's not easy. We'll see, I guess. I'm here to help, and if it works, you should be able to do a t-test quite easily. It's explained in the help file of the t-test. If you don't remember what different t-tests are for, just use the default one. The point is to check that your data is read correctly. Okay, then the medium one is actually using the same Qpcr data that I just showed you, because actually there are 3 tabs over here. Let's see if I can make the whole thing a little bigger. It's easier to see. Yeah, so there are 3 versions. The first one is my dream. This is what I wish students would send to me, and also scientists would send to me. This is more common in people that follow the course but still aren't quite sure how to do it correctly. And yeah, believe it or not, this is what I get sent more often, which it looks more intuitive. I understand if you've never had a course in analysis that this might make sense to you, but this is a nightmare to read in R. Yeah, the hard exercise, don't try it if you don't want a headache. It's called headache for a reason. It's to convert this into tidy format using R functions. Yeah, but this one should be doable, I think, but we'll see. Okay, let me go back. Yeah, so that's the exercise of today. Last thing I want to say before let me see if there's any questions. No. Okay, last thing I want to say is tomorrow is going to be a little bit different. So yeah, the first day swirl I think is really useful. Oh yeah, that I also wanted to say, if you haven't yet, finish the chapters on swirl. I looked up which, particularly number 6 and 7. Yeah, especially if you try these exercises of today and you think, well, that's too hard, I have no idea where to start. Do swirl chapter 6 and 7. They show what matrices are, what data frames are, and what subsetting is, which is what we're doing. We're rearranging data. It's incredibly useful, also for the general research skills course. So if you haven't yet, the first chapter shows how to install swirl. Try chapters 6 and 7. Yeah? If you've already done number 7 and you've followed the rest of this course, then yeah, just do these exercises. Tomorrow is going to be different. Tomorrow we're not going to do something that's useful for general research skills, but we're actually going to show some programming challenges, like writing a function and doing something slightly more complicated. The only reason I'm doing it is yeah, for people who like R and want to learn a little bit more of what you can do with it. If you're just here to make general research skills easier, I recommend just sticking to this. And if you haven't yet finished the swirl chapters, yeah, you don't have to give tomorrow's exercises a stab, because they do require that you actively search online how it works. Are there any questions? Yeah.
Ja, is er een voordeel aan dat je de dataset typedient in R zelf in plaats van het gewoon eerst typedient in bijvoorbeeld Excel of Google Sheets en dan Qpcr?
Yeah, so very good question. Forgot to mention. She asked, is it not just easier to fix it in Excel? Yes. So for these examples, these are very small data sets. It's just a couple of operations, and you can just click and drag, and it's in tidy form. Much easier. But most experiments, you have much larger data, and also, for example, if you do your internship on the LUMC, they don't allow you to do it in Excel, at least in some divisions, because copy pasting is error prone. So it's dangerous, especially when you have a large number of variables, long data sets with repeated measures. If you miss one cell or something, then your results are completely scrambled. So copy pasting is dangerous business. For small data sets, sure, it's easier. If you are the one collecting data, of course, I really hope that you try to collect it like this. But if you are presented with a large data set that's untidy, it's better to do it with a program, like with R. Any other questions? Okay, then let me check once more. Yeah, no questions here as well. Yeah, that's all for the explanation. I'll be here to help with the exercises, and I'll also have a look at Brightspace every now and then to see if there's any questions. Good luck.